Good day, grade 9s. Welcome to the work. My name is Mrs. Ernston, and I'm the WorksheetCloud grade 9 natural sciences teacher. Now, we've got a really interesting lesson coming up, so you definitely need your paper and pencils, and then you're going to need a whole lot of other ingredients as well. So if you don't have the ingredients in and around the house, not a problem. When your parents next go to the shops, if you can just put it onto the shopping list, and they can get everything you need and bring it back, and then you can have fun at a later stage with our chemistry kitchen lesson today. Well, if it's your birthday today, I really would like to wish you happy birthday, and I've got a special surprise for you today. So just hang on a moment.
Today's gonna be A-okay, cause we're celebrating your birthday. Happy birthday to you, celebrating your birthday.
The topic of today's lesson is kitchen chemistry, and we're going to be having a look at the science and magic behind making honeycomb. We're also going to revise a little bit from each of the topics we've done over the last few lessons. So defining compounds, atoms, molecules, talking about the periodic table, how to name compounds, chemical reactions, balancing chemical reactions, and what do all the symbols and numbers in the chemical reaction mean. So to engage in the lesson, I would like you to look at this crunchy chocolate that we have up in front of you. And I would like you to do the following activity, whereby we write, I see, I think, I wonder. So when you look at this yellow bit inside the crunchy here, have a close look and tell me, what do you see? And then you can write everything that you see down. And then I want you to write, well, when you see whatever it is you see, what does it make you think about? And once you've done that, I want you to let your mind be creative and write down, well, what does that make you wonder about? And try and find the wonderment and creativity and your critical thinking about everything that happens when you look inside a crunchy. If one of your favorite chocolate bars is a Cadbury's Crunchy, then you've probably spent a lot of time staring at those holes and bubbles inside it before you take your next bite. And you might have wondered, well, how do the bubbles get there? How are crunchy bars made? Well, the bubbly center underneath all that delicious chocolate is called honeycomb. It's also known as cinder toffee or hokey pokey. So let's learn how we can make some honeycomb and find out the science behind the bubbles. So making honeycomb requires standing at a stove top or a hob, maybe even the flames of a gas stove, and you are going to be melting sugar in a pan, and the temperature is going to get really, really hot. And I want you to just make sure that when you do this experiment that there are definitely grown-ups around at all times, and please don't ever touch the flame with open hands or the contents of the pan or anything like that. So please stay safe, keep safe, and remember all your safety precautions when heating substances. So the ingredients for this activity are fairly simple, and some of you may be lucky to have these around the house. So just go scratching through the kitchen and pantry, obviously with your parents' permission or guardians' permission or caregivers' permission, and check that you have these items around the house. If not, please ask your parents if they could maybe buy them for you when they next go to the shop so you can do this fun experiment. And if maybe your parents say no, then just hang on, and it's something to look forward to when you get back to school, and maybe you can share this recipe with your science teacher and maybe you'll be able to do this recipe back at school. So you need a product called bicarbonate of soda, and then you need some white sugar, preferably plain white granulated sugar, not caster sugar or icing sugar. But if you've got them, they might be able to work. You can try it. I know I've only ever used sugar. And then you'll need some syrup and some water. So here are our honeycomb ingredients and apparatus. You need 100 grams of sugar, 1 tablespoon of water, 2 tablespoons of golden syrup, 1 heaped teaspoon of bicarbonate of soda, a large saucepan, so a pot or a saucepan will be fine, preferably a wooden spoon, and then a baking tin or a baking tray that you've lined with some tin foil, aluminium foil, or greaseproof paper. This really can turn out to be a sticky mess. So I don't want you to pour this mixture into a pan. So definitely some foil or greaseproof paper. It will also help you when you have to tidy up and wash up. So just a reminder, there are lots and lots of different recipes that you'll find on the internet for making honeycomb toffee. But I have generally found that this is the one that I use with the pupils that I teach, and it's one of the simpler ones. And here are our instructions. So I will move out the way up here by the B, and let's go through these step-by-step instructions. First, line a baking tray with silver foil or tin foil, aluminium foil. Then mix the sugar and syrup together using a wooden spoon and a saucepan, but start off placing it on low heat. Stir this mixture until all the sugar has dissolved. So if you drag a wooden spoon over the saucepan base and it still feels a little bit gritty, or you can feel it sort of crunchy, then it hasn't quite melted. So you don't want to feel these granules. You want to feel it to be nice and smooth. So please be patient when you carry this experiment out. I know if you try and hurry it and heat it up and speed it up, you're going to sit with a burnt, sticky mess. So just heat this sugar up slowly. So that's going to take you about 10 or 15 minutes. Once your sugar has all melted, then you can turn the heat up a little bit higher so that it starts to bubble and that you definitely don't see or feel any granules at the bottom. Then I don't really want you to stir it too vigorously at this stage, but you can swirl the contents a little bit from time to time, and you can stir, but just slowly. It isn't really that necessary. Once all the sugar is melted, you're going to see these bubbles are going to start forming, and the sugar is going to start caramelizing. It's going to turn a light brown amber color. Now you've got to be very quick and very careful here, because if you let it go too long, it's going to go brown really, really quickly, and your sugar is going to start to burn. So just as it's turning a goldeny color, please take it off the heat immediately. Then I want you to add your bicarbonate of soda and stir and whisk. And you will see that as you add this bicarbonate of soda, you're going to get an amazing chemical reaction happening. And your mixture is going to just transform itself into a puffy mass. Watch what it happens. It's just lovely to see it froth with all these lovely bubbles. Then I want you to pour the mixture into a baking tray. If you've got a mold or something, you can, but just remember you've got to clean the sticky mess up. And you don't want to spread it around too much, because then you might pop the bubbles. So it's best just to slowly just turn the contents of the pan out into a lined tray and just let it settle. Then now you need to be really patient, because you need to allow the mixture to cool, and it should take easily an hour for that mixture to cool. So you can go and do another WorksheetCloud lesson in the meantime, or you can work through the worksheet that's associated with this lesson, or you can go and do some science revision. And then once it has solidified and cooled, you're going to get these delicious, tasty treats, and you can add any extra ingredients, cream, ice cream, chocolate. Here's your opportunity to be as creative as you can. Okay, so that was the fun part of the lesson. Let's go back to linking up the content with this lesson. So why is the honeycomb full of bubbles? Well, the bicarbonate of soda breaks down with heat to release carbon dioxide gas. And the gas causes the sugar and syrup mixture to froth and bubble. The bubbles become trapped in the mixture where they set as the mixture cools. How amazing is this science? So if we just go behind the scenes, the science behind the honeycomb. So, yep, you have worked out that the secret ingredient in this mixture is the bicarbonate of soda. And that is the magic ingredient to making honeycomb. So because the sugar mixture is hot, it gets working with the bicarbonate of soda straight away. You saw that foamy, fizzy transformation. The heat from the sugar mixes and breaks down the bicarb, forcing it to release this carbon dioxide, which is a gas. And this happens almost immediately. The gas is what causes the bubbles in the honeycomb, and the bubbles make the mixture expand and they create a light, bubbly texture. So, the uses of sodium bicarbonate and some of the scientific explanations around that. So, sodium bicarbonate is the common household name for it. The IUPAC name is sodium hydrogen carbonate. It is also commonly known as baking soda or bicarbonate of soda. And the chemical formula for this is NaHCO3. So in actual fact, it is a type of salt. It's not quite like the salt you put on your food, but it is a salt. If you have a look at the powdered form, they are tiny, tiny little crystals. And they're made up of sodium ions and bicarbonate ions that have chemically combined. So sodium bicarbonate is a white solid. It's crystalline, tiny little crystals, but they often appear as a fine powder. And it does have a slightly salty alkali taste. So if you just dip your finger in it and have a taste, it's not that nice. So just some recap. We did these matching columns a few lessons ago. So if you need to pause the screen while you match the words up with the definitions, you can. I'll wait for you. So just to recap, an atom is the smallest particle of a chemical element that can exist on its own. An element is a substance made up of particles that are called atoms, and in an element, all the atoms are made of the same type. A compound is a substance that is formed when two or more elements combine chemically, and a chemical reaction must have taken place for a compound to form. And a mixture is a collection of different substances. The particles of a mixture will not be the same, and there will be a number of different types of particles in a mixture. Now, this slide has come from one of our early lessons where we looked at atoms, elements, compounds, and molecules. So if you've only joined our lesson now, please go back into our previous lessons and go and have a look at some of the work that we have covered this term. So the other thing that we covered this term was learning all about the periodic table. And remember that we find metals on the left of the periodic table, and non-metals on the right of the periodic table, and metalloids in between the metals and the non-metals. And we also spoke about what atomic number and symbol and name and mass mean. So you can go and have a look at those previous lessons. What is important, and a reminder, I know your teacher will want you to do it, and that is to definitely learn the names and the symbols of the first 20 elements. You don't have to know them off by heart, but you definitely need to know them. And then the other thing, remember, when using the symbols for the elements, it's either going to be written with one letter or two letters. The first letter is always a capital letter, and the second letter is always a lowercase letter. So, for example, hydrogen is capital H, whereas helium is capital H and lowercase e. And that's how we can differentiate between the elements. So every element has its own unique symbol. And I did also impress upon you, when you do have to write the names of the elements and the symbols down, please could you be exceptionally neat. And then just to recap, learning how to name compounds. And how do we name a compound when we are mixing a metal and a non-metal? Well, generally the metal comes first, or the naming of the metal comes first and the non-metal second. And then the name of the non-metal is going to change. We're going to add a suffix, which is something we put at the end of a word, and that is going to be IDE. So, for example, if we have a look at these compounds here, and we use the periodic table to help us try and remember how to name those compounds, NaCl is sodium chloride. We don't say sodium chlorine, sodium chloride. LiBr is lithium bromide. MgO, magnesium oxide. FeS, iron sulfide. And then sometimes we do find that non-metals chemically combine. And how do we go about naming those? Well, generally, the non-metal that is further to the left, we mention first. We write that down first. And then the other non-metal we write second. And then we differentiate the two depending on how many atoms we find in the compound. So when there is only one atom, for example, we use the word mono. When there are two atoms, we use the word di. When there are three atoms, we can use the word tri. When there are four, we can use the word tetra. So, for example, CO is carbon monoxide. You will just notice that we don't go mono-oxide, it's monoxide. CO2, for example, is carbon dioxide. Then NO2 is nitrogen dioxide. So here we have a tricky one. What happens when we get to N2O4? Well, to let your teacher know that you understand that there's two atoms of nitrogen, it's dinitrogen tetroxide. And then, for example, sulfur and oxygen, it's sulfur dioxide and sulfur trioxide. So you might need to go and recap this lesson. It's all about naming compounds. And then sometimes we do find that in a compound, the last two or three elements may be grouped together. So the common ones you'll come across in grade 9 are sulfate, sulfite, nitrate, nitrite, carbonate, and hydroxide. Just double check with your teacher if there are any other ones that they want you to learn, but these are the general ones that we'd like grade 9s to learn. And when that happens, we just add 8 or 8 at the end of the word, depending on how many oxygen atoms there are in the compound. So generally, your teachers just tell you to go and learn this. So here we have the chemical formula, NaHCO3. And this is the chemical formula of the magical compound that we used in the kitchen today. So the IUPAC name, the official scientific name, if you had to give the scientific name of this compound, remembering all the rules, it's sodium hydrogen carbonate. There are common names like sodium bicarbonate or sodium bicarb. So what is this substance made up of? It's made up of one sodium atom, one hydrogen atom, one carbon atom, and 3 oxygen atoms. That is how many atoms we'll find in one molecule of sodium bicarbonate or one molecule of sodium hydrogen carbonate. So just to refresh your memory on what chemical equations are, when we represent a chemical equation, we do it in terms of chemical symbols or formulae. and we call this a chemical equation. So, for example, the chemical equation for making water is 2 molecules of H2O plus 1 molecule of O2 gives us 2 molecules of water. Now, what do we do when we have this equation here? So here we have our sodium bicarb, and here our sodium bicarb is broken down into sodium carbonate, water, and carbon dioxide. So the first thing to remember is in a chemical reaction equation, we look for the arrow. The arrow is an indication that we have had a chemical reaction. Then, in a chemical reaction, everything to the left of the arrow is known as your reactants, and everything to the right of the arrow is known as your products. The numbers in front of the chemical symbols are known as coefficients, and they tell us the number of molecules that are taking part in the reaction. And the numbers at the bottom of the elements inside the chemical equations or inside the chemical formulae, those are known as subscripts, and they refer to the number of atoms that are part of the element or the compound. So what you can go and do, and you will find it very interesting, is to research the variety of different uses of sodium bicarbonate. And I definitely know your teachers would like you to brush up on research skills. So with your inquisitive minds, go and explore all the different uses of sodium bicarbonate. I am sure you're going to be intrigued at all the different uses. It will even give you more leverage to ask your parents or guardians or caregivers to go and buy you some sodium bicarb. It has so many different uses for around the house. So to evaluate how you've done this lesson, you can try and answer, how do we know that this is a compound? A compound is a substance that is formed when two or more elements chemically combine together. So a chemical reaction must have taken place in order to create a compound. And then here you have a chemical equation, and I wonder if you can remember how to balance chemical equations. So pause the video now while you try to balance this chemical equation. And now let's go through and see if you were able to do it. So what you do is you write out the chemical equation, and then where the arrow is, you put a line down there. So what we do is we are separating the reactants from the products. And then what you do is you make a list of all the elements that take part in this reaction. So we have sodium, we have hydrogen, we have carbon, and we have oxygen. And then you just want to check that the elements on both sides of the equation are correct. So we have sodium, carbon, oxygen we find 3 times, hydrogen and carbon. Then just a couple of hints and tips with balancing equations. Leave the hydrogen and oxygen to last. Start with the metal first, then move on to any other non-metals. And sometimes it might be beneficial where you see compounds grouped together, like carbonate, you can keep those grouped together if you would like. But today I've separated it out. So if we start to have a look here, we have 1 atom of sodium, 1 atom of hydrogen, 1 atom of carbon, and 3 atoms of oxygen. So those are the atoms in the reactants. Now if we move to the products, we've got 2 atoms of sodium, 1 atom of carbon here, but there's another atom of carbon here. So with the products together, we have 2 atoms of carbon. Oxygen we have 3, 4, 5, 6 oxygens, and hydrogens we have 2. So the hint is to start with the metal. So on the left-hand side, on the reactants, I've got 1 atom of sodium, and on the products, I've got 2. So if we start out by adding another molecule of sodium hydrogen carbonates, that will balance out the sodiums. So now we have 2 sodium atoms, but in the process of adding another molecule, I've added another 2 hydrogen atoms, and I've added another 2 carbon atoms, and I've now added 3 times by 6. I've now got 6 oxygen atoms. So let's go and see if our equation is balanced out. Yes, it has. Well done. I'm very proud of you. Okay, so this brings us to the end of our lesson, and I just want to congratulate you on how passionate and enthusiastic you have been. I know everything seems impossible until it's done, and that is just a quote from Nelson Mandela that I absolutely love, and it definitely is getting me through this time of lockdown. So I know you're just looking at your work and you're thinking, wow, it's impossible. But I do just want to thank you for joining me today, your passion, your enthusiasm. So grade 9s, thanks so much. More importantly, I'd really like to thank WorksheetCloud for bringing you this lesson today. And now I hope you go off and have a lot of fun making honeycomb.